Okay, in this section, we're going to talk about systems of equations, and this time we're going to talk about applications of them in the real world, and when you can use a system to help you solve out a real-life situation. So let's take a look at this real-life situation here that we have. It says, your family is planning a 7-day trip to Florida, and you estimate that it will cost $270 a day in Tampa and then $400 a day in Orlando. And your total budget for the trip, the 7-day trip, is $2,300. How many days should you spend in each location? So obviously some research has been done on just the cost of, entertainment and food and things of that, and those two specific destinations. So now it's just a matter of, okay, well, where should we spend our time when we get there? So when you're solving a system of equations word problem, I always like to break it into these 3 steps to help you solve. The first step is to define your variables, define your unknowns. What are you looking for? Then create your system of equations. So create your equations, which honestly is always the most challenging part of these problems. And then once you have that system, you're going to go ahead and solve it. So let's go ahead and take this one and figure out what our unknowns are. Well, we know that we're going on a trip for 7 days, and we know that we're going into 2 different locations. Now, if you look at your question at the very end, it says, how many days should you spend in each location? That kind of gives you a hint on what your variables are going to be. So in our case, we're going to say that X is going to be our days in Tampa. And then we're going to call Y our days in Orlando. Okay, now that we have our variables defined, let's go ahead and start the challenging part, constructing an equation. So I always like to look at the system that we're creating as the first equation is going to be the very simplistic equation, something that's very basic. And then the second one's going to be the one that is more complex and that incorporates more of the numbers that are given to us in the problem. So our first equation here is going to be very simple. What we're saying is that we're going on a 7-day trip to Florida, and we want to figure out how many days in Tampa, how many days in Orlando. So I'm going to represent that by saying how many days in Tampa plus how many days in Orlando is going to equal 7 days total. That's very simple, very basic. Now I'm going to start incorporating those numbers that are within my word problem to create my second equation. So you can see that it says $275 per day in Tampa and then $400 per day in Orlando. I'm going to incorporate those numbers into my next equation. I'm going to say 275 days in Tampa plus 400 days in Orlando. And that's going to be equal to, well, what was our budget for this problem? Well, it was $2,300 for those 7 days. So I'm going to set it equal to $2,300. Now that I've created my system, I can go and solve it. Now, this is where we need to ask ourselves, what is the best method to solve the system of equations? We have the graphing method, we have elimination using adding and subtracting, we have elimination with multiplication, and we have substitution. After looking at this, I personally think the substitution would be the best method because I could take that first equation and I could solve it for one of the variables. I'm just going to go ahead and solve it quickly for X. That would give me X equals 7 minus Y. Now that I have X by itself, I'm going to substitute that X into my second equation. That's going to give me 275. Now my X, again, my X represents this chunk right here. So I'm going to say times 7 minus Y. And then I'm going to finish off the problem. Plus 400y is equal to 2,300. Okay, from here I'm just going to go ahead and distribute and solve my multi-step equation here. So I have 1925, feel free to use your calculator as well, minus 275y plus 400y is equal to 2,300. I'm going to combine like terms on my left-hand side. So 1925 plus 125y equals 2,300. And I'm going to go ahead and I'm going to subtract that 1925 from both sides to get him out of the way. And that's going to give me 375. All I'm doing right here is solving a multi-step equation. That's all. Okay, so y is going to equal 3. All right, well, if we go back to where we defined our variables, we can see that y represents the number of days in Orlando. So we are going to spend 3 days in Orlando. Now, to figure out how many days we're going to spend in Tampa, we're going to treat this just like we've treated all of the other systems that we've done. We've taken that value and substituted it back into one of our equations. Obviously, the first equation is going to be way simpler to substitute it in than the second one, so I'm going to go ahead and choose that. And you can see that x is going to give us 4. So we're going to spend 4 days in Tampa and 3 days in Orlando. Okay, so that was one type of application of a system of equations. Now I'm going to show you a different one. It's still the same process, and we're going to be using that same structure, but now it's just going to look a little bit different. All right, now we're going to look at Carlos Bakery. I love Carlos Bakery. I went there a couple years ago. It's right across New York City in a little town called Hoboken, New Jersey. Really cute and really yummy baked goods. So here we go. We have at Carlos Bakery in Hoboken, New Jersey, one customer pays $5.67 for 3 bagels and 4 muffins. Another customer pays $6.70 for 5 bagels and 3 muffins. How much does a single bagel and a single muffin cost? So what you can see here are there 2 separate customers coming in and buying 2 separate different orders of baked goods, and they give us the total price of each. What we're trying to do is use that information to figure out the cost of a single bagel and a single muffin by itself. So obviously what we're trying to figure out is that X is going to be the price of a bagel. So I'm going to say that that's the price of a bagel. And Y is going to be the price of a muffin. So I'm just going to define it just so I know that this is what I'm talking about in the problem. And the reason that this system is different is that I have 2 different customers. One customer paid $5.67 for 3 bagels and 4 muffins. That's going to be my first equation. I'm going to say that 3 bagels, so 3x, plus 4 muffins, 4y, is going to be equal to $5.67. My second equation is going to be my second customer. The other customer paid $6.70 for 5 bagels and 3 muffins. So let's go ahead and put that in there. 5x plus 3y is going to be $6.70. Now that I've constructed my system of equations, now I want to determine which method I want to use to solve it. Now, we could graph this, but I don't really think that any of us really want to graph the decimals in there, so maybe there might be a better option. Substitution, we could use substitution, but probably not the best method. I would most likely lean towards the elimination method with multiplying, because it looks like we can easily make those x coefficients or those y coefficients the same. So I think what I'm going to do is I think I'm going to make the x's the same. I think that might be the easiest thing to do. So I'm going to do that right up here. I'm going to multiply the top equation by 5. And it's going to look something like this. And then I'm going to multiply the bottom one by 3, and it'll look something like this. If you remember this from this section, you always want to write this step because now we're actually going to do the distributing. So that's going to give us 15x plus 20y is equal to $28.35. And then if we multiply 3 by the bottom equation, that's going to give us 15x plus 9y is going to be equal to $20.10. Okay, now that we have those x's the same, now we can use our elimination method, and I'm going to subtract them. And that subtraction will eliminate them. And so then we have 20 minus 9 is going to give me 11y. And if we subtract those decimals, it's going to give us $8.25 or 8.25. Simplify it, divide by 11, and my y is going to be 0.75, or in our case, we're talking about the price of a bagel and a muffin. So the price of a muffin is going to be 75 cents. Okay, and now we need to figure out the cost of our bagel. So just like before, we need to select one of the equations to substitute it back into. And I'm just going to go ahead and choose the first since it's right there. I'm going to say 3x plus 4 times my 75 cents is equal to $5.67. Keep simplifying down. Feel free to use your calculator to calculate and compute these. Subtract 3. 3x is equal to $2.67, and divide both sides by 3. That will give me x is equal to 0.89, which, of course, we're talking about money. So the cost of a bagel is going to be 89 cents, which is actually, it seems pretty cheap. I can imagine that at Carlos Bakery, it would actually, the cost of a bagel and a muffin would be a little bit north of less than $1. But either way, for this problem, it kind of shows you how you can use the system to figure out the price of each of these. Okay, I do have some more examples for us today. This is one of my favorite ones because it's actually really, you're probably going to see something like this when it comes to your SOL. Your SOL, they love putting questions like this, talking about nickels and dimes. So I put one of these in the notes. So let's look. Irene has $4.50 in her coin bank in nickels and dimes. And the number of dimes is twice the number of nickels. How many coins of each type does Irene have? Well, obviously, we're talking about nickels and dimes here. So I'm going to say that X is going to be my nickels, and Y, or D you can do, is going to be my dimes. Feel free to use different variables. I just usually use X and Y, but feel free to use N and D if you'd like. Okay, now we're going to create two equations. And of course, this one's a little bit different as well. Because the first equation is going to be the money equation. It's going to be the one that is going to be representing all the money that everything represents. So here we have nickels and dimes. We know that nickels are 5 cents and dimes are 10 cents. So what I'm going to do here is I'm going to say 0.05x plus 0.10y is going to be equal to $4.50 because that is how much money Irene has in her bank. Now, this one is different because we have this sentence here. The number of dimes is twice the number of nickels. Well, we have to do a little bit of translating here, don't we? The number of dimes, which is y, is equal to twice the number of nickels, x. So now we have our system of equations. All right, now that we have our system, there are a couple different things we could do here, but I personally think that substitution is definitely the best option because we already have a variable simplified down to itself with a coefficient of 1. So what I'm going to do is I'm going to take that second equation and we're going to substitute that y into the y in the first equation. So let's go ahead and set that up. 0.05x plus 0.10. Now I'm going to substitute my y in there, which is 2x, and that's going to be equal to $4.50. All right, I'm going to go ahead and simplify that down here. All righty, let's do 0.05x plus 0.2x equals 4.5. I'm going to combine those like terms there. That's going to give me 0.25x is equal to 4.50. And of course, I'm going to go ahead and divide both sides by 0.25. And that's going to give me x is equal to 18. All right, x represents my nickels. So I'm going to end up with 18 nickels in the piggy bank. And then I need to figure out how many dimes do I have. Well, I'm going to go ahead and plop that right into my second equation because that's a pretty easy equation to substitute it into. That's going to give me 36. So 18 nickels and 36 dimes is going to be what is inside the coin bank. All right, I have one more for you here, and this one is my favorite. This is going to be something called a mixture problem. In this problem, what we're going to be doing is we're going to be taking two different things, two different liquids in our case, and putting them together to make a new liquid. Let's go ahead and read this problem. A dairy owner produces low-fat milk containing 1% fat and whole milk containing 3.5% fat. How many gallons of each type should be combined to make 100 gallons of milk that is 2% fat? So basically, the gist of the problem is we're taking 1% milk and we're taking 3.5% milk. We're putting it together and we're trying to create 100 gallons of 2% milk. So what we want to do first is define our variables. Obviously, we have our 1% and our 3.5%. That is going to be those are going to be the variables that we're working with. So let's call X. This is going to be our 1% milk. And we'll say that Y is going to be our 3.5% milk. All right, now the equations. Again, I'm going to start with a very simple equation first. I'm trying to make 100 gallons, and I'm trying to look for, well, how many gallons of 1%, how many gallons of 3.5%. And you know what? I'm actually going to write that up here just to remind myself that these are gallons that we're looking for in these variables. So really what I want to know is how many gallons of 1% plus how many gallons of 3.5% are going to give me that 100 gallons. That's my nice, simple equation. Now let's beef it up a little bit. Let's make it a little bit more complex. Now, the X represents 1% milk. Let's go ahead and represent 1%. We're going to say 0.01X, and then we're going to represent our 3.5%. We have to move that decimal over to give us that decimal of 0.035Y. Now, this is the most forgettable part of a mixture problem. We're trying to make 100 gallons of 2%. So right here, I need to not only write my 2%, but I need to multiply it by 100 because I'm trying to figure out 100 gallons of 2% milk. So now that I have this mixture problem set up, I have my system. So I can go ahead and solve it. All right. So I personally think that substitution is going to be the best method here. So I'm going to take that first equation and I'm just going to solve it for X. You can solve it for Y if you prefer, but it's going to give me 100 minus Y. All right, now I'm going to go ahead and take a second and plug it into my second equation. So 0.01, and I'm going to multiply that by 100 minus Y. And then I'm going to add 0.035Y, and I'm going to set that equal to, I'm just going to set it equal to 2 because we know that 0.02 times 10 is going to be, or times 100 is going to be 2, so I'm just going to keep it at 2. All right, let's go ahead and distribute 1 minus 0.01Y plus 0.035Y is equal to 2. A lot of number crunching here. And keep it going here. 1 plus 0.025y is going to equal 2. I'm just going to simplify this down. I'm just going to subtract 1. 0.025y is equal to 1. And if I divide that, I'm going to get y is equal to 40. Okay, 40. Well, what does y mean? Y is 3.5% skim milk, and so that's going to be 40 gallons of 3.5% milk. So that's 40 gallons. Now I need to figure out, well, how many gallons of 1%? Well, let's substitute that y into my first equation. So x plus 40 is going to be 100. Sorry, that looks like a 6. 100. Subtract my 40. And that's going to give me my x equals 60. So I'm going to have 60 gallons of my 1%. So 60 gallons of 1% and 3.5 gallons of 3.5%, if you pour those together, that's going to create 100 gallons of 2% milk. All right, those are 4 really good examples of systems of equation application problems. And we'll do some more practice of this as the days go on.